Welcome back to Lead Insight, the podcast where we cut through the noise and bring you actionable intelligence on the strategic application of artificial intelligence. I'm your host, Ajay. Today, in episode 2, we're tackling a critical strategic decision point, understanding when to effectively deploy generative AI versus our more established predictive AI tools. This isn't about choosing a favorite technology. It's about aligning the right AI capability with a specific business challenge to drive tangible results. Think about the journey we've been on in analytics. Over the last decade, many of your organizations have moved from foundational statistical modeling through the power of machine learning, and some have even integrated the more nuanced capabilities of deep learning. Now, the emergence of generative AI adds a fascinating new dimension: the ability to create. This evolution, while exciting, naturally raises important questions about optimal application. At its heart, the decision boils down to this: are we trying to predict something, or are we trying to generate something new? While the allure of generative AI is strong, its most effective role in conjunction with our existing predictive AI infrastructure requires careful consideration. Our discussion today aims to provide a practical framework to navigate this crucial intersection. Let's first revisit the bedrock of much of our current AI deployments: machine learning. This is about identifying patterns in your historical data, such as sales figures, customer behavior, and operational metrics, to make informed predictions or automate decisions. Its strength lies in its ability to handle structured data, the kind you find in your databases and spreadsheets, powering applications you likely already leverage for forecasting, customer retention, and risk management. Then we have deep learning, a more advanced subset of machine learning. Its real breakthrough has been in processing unstructured data, such as images, voice, and text, without the need for extensive manual preparation. This opens up a wider range of possibilities, particularly when dealing with complex, multifaceted data. However, it's important to remember that deep learning typically requires larger datasets and can be less transparent in its decision making process. Now, the game changer: generative AI. The fundamental difference here is the ability to create novel content. Built on sophisticated neural network architectures, these systems can produce human like text, realistic visuals, even functional code. This opens up entirely new avenues for innovation, from personalized marketing at scale to accelerating content creation and even streamlining software development. Predictive AI takes data in, often structured, and outputs predictions, classifications, or numerical forecasts. Generative AI typically takes unstructured data and produces new, original unstructured content. Understanding this fundamental difference in input and output is key to aligning the right AI with the right task. So, how do we make this crucial determination? The most logical starting point is the very nature of the business problem we're trying to solve. Is the desired outcome a prediction such as categorizing customers, forecasting demand, assessing risk? Or is it the creation of something entirely new, such as marketing copy, product visuals, software components? This initial assessment will steer you in the right direction. When the objective is clearly to generate novel content, the path is relatively straightforward. Generative AI is the tool of choice. Depending on the specific output, you need text, images, video, or even specialized formats. There's likely a generative AI model tailored to that task. Now, for prediction problems where your primary data source is structured and tabular, our recommendation leans towards traditional machine learning. While deep learning can be applied here, it often introduces unnecessary complexity in terms of model tuning and interpretability. Established ML techniques are generally faster to deploy, easier to understand, and often just as, if not more, accurate for this type of data. The landscape has shifted significantly when it comes to prediction with unstructured data. Previously, deep learning was the standard approach. However, the advancements in large language models now offer a compelling alternative. For many tasks involving everyday language or common image recognition, these models can often perform effectively right out of the box without the need for extensive specialized training. Consider a practical example: analyzing customer reviews to identify product improvement ideas. Traditionally, this would involve significant data labeling and training a custom predictive model. Today, we can often simply prompt a large language model to classify these reviews effectively, demonstrating the power of applying generative AI techniques to prediction tasks involving natural language. Furthermore, many of today's leading language models are now multimodal. They can process and understand not just text, but also images, enabling tasks like image classification, object detection, and even extracting structured information from visual documents. This expands their utility in prediction scenarios involving more than just text. It's crucial to recognize that large language models aren't a universal solution. There will be situations where their accuracy is insufficient, the cost of API usage at scale becomes prohibitive, real time processing demands are too stringent, or data privacy concerns limit their applicability. In these cases, a dedicated predictive AI approach, often leveraging deep learning, remains the more appropriate path. When dealing with complex unstructured prediction tasks where the limitations of large language models become apparent, deep learning offers a robust alternative. The key here is to leverage the wealth of pre trained models available. These models, already trained on vast amounts of similar data, can be fine tuned with your specific data, significantly reducing the data and computational burden. Generative AI can even play a crucial role in enhancing our predictive AI efforts. Large language models can be used to cost effectively label the data needed to train deep learning models, or even generate synthetic data when real world data is scarce, streamlining the development process. Finally, when your prediction problem involves a combination of structured and unstructured data, perhaps patient records alongside medical images, our recommendation is to lean directly into deep learning. These models are specifically designed to handle and integrate diverse data types for more comprehensive insights. To bring it all together, we've outlined a decision framework to guide you through this process. By first defining the nature of your problem, such as generation or prediction, and then considering the type of input data, you can navigate towards the most effective AI approach. Ultimately, the most impactful AI strategies often involve a thoughtful blend of these capabilities. It's not an ether proposition, but rather a strategic orchestration of different AI tools tailored to the specific nuances of your business challenges. And as the technology continues to evolve, we'll likely see even more powerful hybrid approaches emerge. The key takeaway for us as business leaders is to remain informed about these technological advancements while steadfastly focusing on our core business objectives. By adopting a structured decision making process and always prioritizing value creation, we can confidently navigate the evolving AI landscape and ensure our AI initiatives deliver meaningful and measurable results. Join us in our next episode as we explore another critical dimension of AI strategy for forward thinking leaders. Until then, lead with clarity and precision.